you'll be able to talk. Okay, as we were saying there, we started getting into that function form. The thing that we want you to take away from on Friday was this right here. When I say put into function form, we want to be in that form right here, that ax plus b. So we talked about going from those arithmetic sequences on over to that ax plus b form. Now, on that first word problem here, as we see, that's what we're going to move into. What we have then is you take a minute, read through there. If you've had to clean up at some type of party, maybe at a hole or anything like that, stacking chairs. You know, after a certain part, you can't stack those any higher, or they tend to then maybe go falling down. But I know you never thought about that because there's a mathematical equation hiding behind the scenes. If you thought about that, you're weird. How would you think about that? Okay. But what we're going to do here is kind of model that together here and connect what we did on Friday. So let's take a look and read through that problem on that M2-12 page. At the end of the last show, stage hands, all right, at the community theater, stack the audience chairs and place them in storage. The height of one chair is 34 inches, and as each additional chair is stacked, the height increases by 8 inches. So we've all put chairs inside of chairs before, okay? So what that means here is where that chair height is, let's say it's 34 inches, I know it's all that, okay? The height of those chairs stacked keeps growing. Now, it says it grows by a height of 8 inches. So if this is 34 inches for the first chair, okay, the height of that only grows that much when I put the next chair in there. The reason why the height of that chair is only growing by 8 inches each time is because those chairs are obviously getting nestled one inside of the other. So we start off with 35 above the ground, 8 inches, another 8 inches, another 8 inches, and we keep stacking chairs in. And they keep going nicely into the other ones. So the way you're being rude. So we want to write this out here. What we've created then is what we've talked about before with arithmetic sequences. Where do you start? How do you move? So what is our starting term here? Our height is 34 inches, right? And then how are we moving here? What are we increasing by? We're increasing by 8 inches. So all that stuff that we've done before comes again right back into play. You have a starting height of 34 inches, so we put that first one in, nestle it down with the second one, the third one, the fourth one. It's only growing 8 inches each time. Put together the equation now. We want to do that first one here. When we say the explicit formula, let's review. We talked about this on Friday. For that explicit formula, remember, it looks something like that, where you got to know where you start and how you're moving. We start with 34, and how much are we increasing by? We're increasing by 8. So when they say write an equation, that's what we want to start or keep thinking about. You've done word problems before. Where do you start? How are you moving? You adding 8, subtracting 8, doubling. All right? It's doubling it would be in a geometric. Okay? Now, next thing we want to do is take that equation we just created and put it in that function form right here. So when I say function form, I know it was Friday, and Friday seems like forever ago. But what we want to do is use our skills of taking that 34 plus 8 and making it look like that ax plus b. That's when we say function form. That's what we want it to look like. So with that in mind, what do we say we have to do first there? We got parentheses, so what do we use? We use the distributive property. Okay, as we take and distribute that 8, all right, we don't touch the 34 yet, we just bring it on down. But then what is 8 times n? And 8 times -1. Now I know on Friday, a couple of you were forgetting to multiply right there at the end. 8 times -1, giving you -8. You just said -1 there. Show me those arcs like I keep showing. Okay, after you distribute, parentheses are gone. Then what do we look to see if we can do? Yep. I mean, there's only so many kind of steps in our process that we can do. Distribute, combine like terms, which we have those there, right? Without the variables. So what's going to happen to that 8n? 8n is just going to, yep, drop on down. And then right there, this is where we talked about having that calculator. Get that number in your head, 34 minus 8. You can always use your calculator to check your arithmetic. Somebody, what is 34 minus 8? Yep, it should give me a positive 26 out of that. Okay. So when we did this on Friday, we did a lot of work of rearranging it, getting it to look like this. Now the only other thing to do is just say y equals 8x plus 26. Give me a second there. But rearranging it, that's where we want to be at. Creating that initial equation and then rearranging into that function form. Okay? Now, as we look around here, all right, let's go ahead and look at the next page. I don't care too much about that. So let's look at the next page. And here's what they've done. This is what we're moving into next. Okay, at some point, it might have been last week or a couple weeks ago. I guess it's been a while. It's been a few weeks now. We hit pause and did a review of slope-intercept form. And the only thing that we've done so far of finding the slope on is from a graph. That rise and run that we've been talking about, calculate the slope from there. That's been from a graph. The next thing we're going to take you to is determining the slope from a table of values as we have right here. So let's take you that next step. So when we talk about that slope, all we've done so far is graphically. Up 2 over 1, up 3 over 5, whatever we need to do. Now we want to figure out, is this table right here and is this table right here considered to be linear? We said we're going to live in a linear world for a long time here the rest of this year, mostly the rest of this year. So how do we get that into check to make sure that it is a linear table and not an exponential table or not a geometric table? What we want to do is do some subtraction, okay? We want to look on the right side and we want to look on the other column, the first column. All I want you to do is do some just quick subtraction there. How are you moving from 34 to 42, 42 to 50, 50 to 58? Find me that consistency. I want that consistency in these tables of how you move from one number to the next. So how do we move from 34 to 42? What do? Add or subtract? Add, and how much? All right, we add 8. Okay, I can see from 34 to 42, that's an 8. How are we going from 42 to 50? How are we going from 50 to 58? Now, we've seen that before. Where did we see that before? We did all that work back on the arithmetic sequences when I gave you these numbers, but not in the table. But I just gave it to you more like this, and I say, hey, what's the pattern going on? And you said, hey, it's arithmetic because you were adding 8. It's the same thing, just a different viewpoint. Okay? Now, the other thing that we want to check here is the left-hand side, the first column, the domain, the x's. We want to make sure that's also being consistent and increasing or decreasing by the same amount. So when you look at that left side, the first column, how do you go from 1 to 2? Add 1, right? 2 to 3? 3 to 4? Do we have consistency on both the left and the right? If you do not see that consistency, what we then say is it's not linear. You want to keep adding 8 every time, and you want to see that plus 1 there each time. So let's answer this first one out. Okay, the first table is linear because, oops, 1 second. It is increasing by, okay, we said rise over run. We keep saying rise over run, rise over run. Rise is the y's, run is the x's. So in this particular case, when I say determine the slope, how do we say that as? 8 over 1 or 1 over 8? These are the y's for the rise. These are the runs. So based off that, what would we say? 8 over 1. Okay, and what's 8 over 1 just become? Just 8. We're connecting what we do with graphs and now to a table. That's just our next stepping stone in the algebra portion. I want to see consistency. Let's go to the next table. Is the next table linear? Okay, I see that 34, 42, and 50. I see that plus 8, right? How do I go from 26 to 34? Is there a plus 8 hiding there? Yep, and that's where your calculators, again, are coming into play. How do you go from 26 up to 34? It is a plus 8. And I want to see that on both sides. I want to see that on the right-hand side, the y's. And I want to see that on the other side as well with the x's. You got to check both of them. If you don't check both of them, it's very possible for the right-hand side to be on plus 8, plus 8, plus 8, to the left side to go 1, 1, 2. Make sure you're checking for consistency. I want to see that 8s and 1s. So because we got 8s and 1s, what do we say here? The table is linear or not? It is linear. And what we're going to do then is the first table is linear. And we'll just say, make it easy, so is table 2. Okay? So because we have that consistency happening, we say we're linear. We are living in the linear world. Whether you like it or not, that's where we're going to live. Let's make sure we learn the lingo of the linear world. Tables need to be consistent. 8s over 1s. 5s over 2s. I already see that, all that on the left and the right just like we did. Okay? Now that's only 2 there. Let's take a look at the next page here. Okay? On the next page, just flip it, or whatever your book does. Okay? We get ourselves, let's take a look at that one up above in that shaded part, and then we'll look right down below there. All right, let's take a look at here. We've done somebody else did some work here. We're checking the work. You're the teacher. So when I look at this here off that table, and you're looking at that work that they did, what do we get going on there? Is that correct work or is it incorrect work? What are your eyes doing from 22 to 17? It should be going down, right? 22 to 17 is going down. But what did they say off to the side? They said a 5, and what did they say that 5 is? So that is incorrect there. What needs to happen is that they did this incorrectly. They should have done 17 minus 22, and what should have been instead? Not positive 5, but negative 5. You guys are all smart enough. You can see 22, 17, 12, 7. That all is going down by negative 5. Now on the other side, the first column, the domain, is that doing the same thing? Do I see that consistency? Yeah, what are we doing there? We're going up by 1. And if I can see that plus 1 there, and on the other side I can see then actually minus 5, then we are linear. But this person did it incorrect. It's a common mistake to do. So trust your eyes. You know what's going on here. It's going down by how much? 5. Okay? So Parks claim the slope is 5. Eva Kate, wherever they get these names from, claims the slope is negative 5. Who is correct? So who is correct? Yep. Eva Kate is correct. So let's use that right down below. I have 3 tables. And on these 3 tables, I want to figure out, are these 3 tables linear or not? So you gather data, and you want to kind of go back to what we said before. Does it make sense to run a linear model or anything like that? We want to figure out, is this table, this data that we have here, is it linear or not? So let's take up that first table, letter A. All right? So trust your eyes. Let's go to the right-hand column. All right? The range, we call it the Y's. I keep saying domain and range. Let's not forget about all that stuff. Okay? What are you doing? 12 to 15. I say you all can read that. 12 to 15 is a plus 3. So how about 15 to 21? What are we doing from 15 to 21? Are we going up by 3? No, we're not going up by 3, are we? We're going up a little bit more by 6. 21 to 30. What are we doing there? 9. By 9. Now, from here, let's look at the other side real quick, the domain. Do I have consistency on the domain at least? Plus 1, plus 1, plus 1. But when I look at this thing as a whole, would we say this is linear or not? No, where is it screwing up at? Left side's cool, the domain's cool, but what's screwing up? The y's are correct. The range is messing up. So on this one here, we're going to say letter A, not linear, because it is not increasing by the same amount. It's got to do that. I want that consistency there. In math, we're all about consistency. We want to see that in our tables. So you guys can add and subtract in your head pretty easily. Keep track of it like I keep showing those plus 1s and plus 3s. Don't try to do that in your head. Jot it down the table like I just did. Okay, letter B. Take a second look at letter B. I always start with the range, with the y's. So I look at those y's. What are we doing in our head there? 18 to 14. Subtracting 4, right? So we're going down by 4. And do we have that consistency happening? 14 to 10? 10 to 6? So this one is on the right track here. We saw those minus 4s, but I gotta check both columns. Let's see if the other side is doing the same. We start off at -2, then we go to -1. How are we going from -2 to -1? Yeah, we're going up by 1. We're going up by 1. We're going up by 1. And then when you take a step back and look at your changes there, what do we say? Linear or not? Always giving the thumbs up there. Already saying linear. So we have a yes, linear table with a slope of, now let's write the slope here. How do I write that slope? We did it a few minutes ago on the other page. 1 over -4 or -4 over 1. It's always the y's over the x's, the rise over the run. The domain is the run, the range is the rise. So we just said what? -4 over 1. And what's that reduced down to? Just, yep, just -4. All right, let's go with one more here. Let's go letter C. All right, looking at letter C then. I always start with the y's. That's, I think, how it's trained. How we go from 1 to 4. Don't overthink it. We can see a +3 there. How are we going from 4 to 9? Yeah, +5, right? That right there should throw up a red flag. 9 to 16 is a plus. Now, on the left-hand side, we see that +1. And I think it might be on Wednesday. We'll slowly change this up. Yes, I got all 1s here, but no, I don't have that on the same side, on the other side. So what do we have here? Linear or not? Correct. That is not linear. We can copy paste that basically down. Let's just say not. We'll just say not linear. Okay? Give you a second. Make sure that's jotted down. All right, screw that up a little bit. So we want consistency always. Now let's make one our own. On that last table there, we want to create our own linear table. Now let's not copy paste the one that was correct, but give me a starting number, somebody. Just say a number.
7.
Thank you. So I'm going to start out with 7 here. Now what have we been increasing by on these x's? We've been increasing by 1, so let's finish it off. 7, 8, 9, and 10. Somebody give me another number. 13. Somebody say positive or negative. Positive, and give me another number. 5. Okay, so I heard positive and I heard 5. So we're creating a linear table I heard positive. I heard 5. So let's go by 5. 13 then becomes 18 becomes then becomes 28, right? All right. Does it have to be increasing? No. I just say give me a positive or negative. Somebody said positive. What if we say negative? All right, then we can make it negative, -5. So let's say we redid that again, but instead of starting at 13, we did a -5. What would that now look like? 13 to -5 gives me a, what, 13 minus 5? Yep, it is 8. -5 again gets me down to 3. A -5 again gets me down to, yes, -2. So, does it matter if we go up or down? No. Okay. Just be consistent like we've been talking about today. We did those 7, 8, 9, 10, and then 13, 8, 3, -2, or 13, 18, 23, 28. We've done that stuff before. Again, I keep going back to stuff we did and you guys did well with. You guys did all that stuff right here, and then I said, make me the next 3 terms of that sequence. And what did I say? The common difference was like 5. And what you did then was, oh, plus 5, and then you put in a what? 23, 28, and then what is that? 33. You guys have done that before. We're just changing the viewpoint a bit. Okay? All right. Give you a second there, and let's see what the next page entails, if it's worth our while or not. I think it is not worth our while, and I think that is where, actually, I think we'll be ready to pause there. We'll pick this back up on Wednesday, okay, where we're at. So give me a second here. Pass out some stuff for today. Let me grab that for you. We'll do a couple of these to start off with. I know it's morning here. They said, across the whole school, second feels really bad. Things fixed. Let's do a couple of these first and we'll do the first one. All right. Let's take a look here. So as we can see on this assignment here today, got some, again, that old stuff just to kind of keep hitting you guys on, because that's going to keep moving us into the next lesson, the next lesson, the next lesson. We're all about living in linear land, and everything that is on here is linear, or possibly linear, on that bottom question with those tables. So we want to check to see if things are linear again and live in that linear land. Now, first thing here is, though, number 2, let's look at letter A. Let's do a few of these to start off with, and what we don't do, you guys can finish it off, okay? All right, so 2, letter A. What we have here then is what? An arithmetic or geometric sequence. It's clearly arithmetic. And what do we have in a common difference? And what number up there represents that common difference? It is at -3. And what number represents the first term then? So as we did today with the chairs, we start off at 34 and we increase by 8. What's this one doing? It's starting off at 7, and what is it doing? Decreasing by 3, right? So this is what's happening on this sequence. All right. Now let's do some old stuff, which is not necessarily old because we've done that lately, just to ask you different viewpoints. When I say find the 42nd term, what do we mean by that? We mean plug in NS42. So I'm going to plug into that equation, NS42. And I kept telling you, especially for my decimals people, do 180 degree subtraction in your head, 42 minus 1, and then go to your calculators and punch that in. Okay? So as we punch those into our calculators, decimals people, make sure, and your graphing calculator people, make sure you are again typing that in correctly. Okay? So as I bring up decimals here myself, what do we got? 7 minus what? 3, and use those parentheses that we keep talking about. Let's make it negative 116 then. Yep. Write that a little bit better.
I thought it was 42.
It's 42 minus 1. Right. So we do that itty bitty subtraction. You good, girlie? You good? Okay, no problem. So what do we get? Negative 116. Okay. Now we want to put that into function form. So function form, whenever I say put it into function form, what I want you to trigger for yourself is ax plus b. That is that function form I keep talking to you about. We started it on Friday, so let's rearrange this into that function notation there. So let's take that parentheses, or that 7 minus 3. I don't have a lot of room here, so I'm going to move it down to the bottom of this. Okay? And just like we did on Friday, we did today a few minutes ago, we got parentheses. Bless you. We got parentheses, so what do we do first? Yeah. Do not do 7 minus 3. You got to distribute the negative 3 first. That's 7, drops on down. And what's negative 3 times that? Bless you. And here's where the silly mistake happens. The next multiplication. Negative 3 times negative 1. Yeah, it should be a positive 3. That's where the mistake happens. A lot of students will say minus 3 again. You gotta watch that arithmetic. Because if you screw up that, you're gonna screw up the last part then. You combine those numbers, but they're gonna be the wrong answer. So that 3n, that negative 3n drops on down. And what is 7 plus 3? So in that function notation we keep talking about, y equals negative 3x plus 10. That's what I want you guys to focus on. Trying to get into that form. We're going to keep working on that this week, next week. It's not going to go away this whole school year. We're going to keep working on it. Keep changing up the viewpoint. All right, let's take a look at number 3, linear or not. These should be a quick one, just like we did our notes. When you look at letter A, go do those y's really quick. Do you see that consistency? And make sure you do it for the whole table. How are we going from 7 to 5? Is that positive or negative? How are we going from 5 to 3? How are we going from 3 to 1? So far, so good. And what should I better see on the other side? That same consistency. Yeah, negative 1 to 0 is a plus. 0 to 1 is a plus 1, and 1 to 2 is a. So let's bring it all together. When you look at that consistency that we had, what does that mean? Linear or not? It is a linear table. So yes, a linear table. Let's go do B and I'll let you do C. What about B? We look at those Y's. How do you go from 4 to 7? Don't think that 4 to 7 is. How do we go from 7 to 10? Now, I always have students say, oh, 3, 3, and we're done. Always check everything that's there. How do you go from 10 to 14? And that's where the mistakes happen. Make sure you look at that whole table, because more likely what we're going to say here is it's not linear. 10 to 11, 11, 12, 12, 13, all those are cool. So what do we say in the end? Linear or not? Not linear. Show me that consistency. I'll let you do the other one for yourself today. Let's look at anything on the back side. What's on the back side, got? Back side is what? Old school stuff, right? That's all my old school stuff with you. And what we start off with reviewing last week on 10 through 13, we kept using now in our notes, combining like terms. So when we look at, say, 12 through 13, let's do number 13 real quick. Oh, thank you, Emma. So let's look at 13 real quick. You got parentheses. So what are we doing there? Yep. And if you're not great with that, keep showing me those parentheses. And when we say distribute, that means what operation is occurring. We are doing multiplication, correct. Use that calculator, check yourself. -8 times a +8. Yep. And a -8 times a -4n. And should be a positive there. Okay? Those are small things to watch out for. Alright? So today, what we'd like you to do is finish that off. Alright? Bring it on up into the basket. You shouldn't have anything to worry about. The only thing I will keep telling you is making sure math is completed. So, once I get going here, I'll bring up where you guys are in math yet. Those are only going to help increase your grades. The end of the semester is not too far away. So let's make sure we're doing those right things. Okay?